What is the correct name of this coordination compound? How would you do it? What do you see first? You see ammonia has 0 charge, cyanide has -1, -6, so the whole thing is +6. I mean, sorry, -6 from the ligands, yes? It's neutral, it's a coordination compound, it's not an ion. You can see the bracket means you have the cation, right? The cation goes always to the left, the anion to the right. So when you see brackets, immediately you know it's an ionic compound. It's not a molecular compound, coordination compound, it's an ionic coordination compound, right? So, -6 from the ligands, you have to have a +6. And the cobalt and the chromium, their sum of the oxidation number has to be +6. All of them have actually +3, so makes sense, right? Now, you don't have to check all this here. In this kind of problem, you do not have to go A, B, C, D and check every A, B, C, D is correct. You know that, how to do that. You just write the correct down and you see which is. Otherwise, you will get confused to go to every one of them, right? You don't care what the A, B, C, Ds are. You just write the correct down and then compare it and pick up the correct one from the choices, correct? You see, we deal with each problem in a different way, right? Okay, so what would you say? We start with what? The cation, yes? Here is the cation and here is the anion. What's the cation? You start first with what? With the ligands, and it's 6 ligands from the Greek prefix hexa. The name of the ligand is amine, with double M, not one single M, unfortunately. So it's hexa, amine. We have 6 ammonia molecules, and it has to have double M, not one. The single M is for something else. So it's hexamine. Usually you put 1A instead 2. You can have 2. If you put 2, that's okay. We're not going to check it wrong. And then what do I have? The oxidation number for cobalt. It says there is 1. Hexamine, and then the name of the metal. And because the metal belongs to the cation, the name stays as the periodic table. If the metal is on the anion, then it becomes 8. That's weird names. Remember these weird names, right? So this is in the cation. It belongs to the cation. It maintains its name as in the periodic table. So it's what? Element, cobalt, therefore cobalt. Hexamine, cobalt, right? And what's the oxidation number? It's as we said, how do I know? It's the whole thing is 0. Yes? You agree with that? Because of the brackets, it's coordination compound, and it's ionic, and it's not an ion. If it was an ion, you would see the charge. So it's 0, the whole thing is 0. Ammonia is 0. Cyanide is -1 times 6 minus 6, right? So -6, I need to have +6. And you can see from here, with a glance, each one of them has 3. So immediately you know it's going to be 3. Most likely, okay? And then what do you have? Then you have to name the anion. Space, you don't have to put a square, I just want to emphasize. There is space, that's the rules. It's not one word, you have space between anion and cation. If it's a molecular coordination compound, you don't have a space because it's a molecule. Here it's 2 ions, cation and anion, you have to put a space. Space, cyanide, cyano, therefore, again hexacyano. And then we have chromium. But the metal is on the anion. It's part of the anion. And if it's part of the anion, we change it. So it's going to be chromium, it's going to be loud. Chromate. Chromate, 1, 2, 3. So the answer then should be 7. Say it. Say it. Say it. Say it. When the teacher played music to say goodbye to you, the 2A people, they start clapping their hands, they participated, they were kind of, some of them anyway, in ecstasy. It didn't happen for 2C people. Why? Because they already are infected. Imagine, by the time you graduate, if you don't take care of business about your health, the mental health, how diseased you will be. This is very serious. The teacher can see the big picture. You don't. So try to see what your teacher is trying to tell you. He's telling you something to think about it. The 2A people were not like dead fish. Why is happening to 2C and to organic people? Because they allow themselves to be tortured by fear and anxiety. Eventually, it will lead you to an accident on the highway, or you will become sick. Your body will become sick. Most likely. One of the two. So try to get your worries away. Just become free. Do it. Your teacher will help you. Huh? Come to the gardens. I'll show you what we did yesterday night, from 3 to 9, actually. Huh? I'll show you what we were doing in the garden yesterday night. 10 people. We'll enjoy the music. Okay, any questions for 7? Yes, what is the question? If you don't see the options, you will not know. You will not really know. Yeah, the information you have so far, you will not know. You could be +2, +4, right? All kinds of combinations. But the problem is that way that you know, okay? What you're saying for 6, that could be what? C? Well, let's look at it. I don't know. Let's see. Shouldn't be true, but sometimes mistakes happen. It might, but I don't think it's a mistake. Let's check it out, though. Huh? So what you're saying is copper 2+, right? What's the configuration of copper 2+? Okay, what's copper? Where's copper? There. So copper is argon, yes? And then you have what? 1, 2, 3, 4s2, 3d9. Never mind? You want me to go ahead or stop? The rest of you, raise your hand. Okay, stop them. So, should be okay, right? The problem is correct. Yes? Okay. Because there's an exception, right? It's 3d10. The electron goes to the D, becomes 3d10, 4s1, okay? All right, so let's go to next. What's the next one? Okay, the next one is easy. You just have to remember a fact about nuclear stability. It has to do with the stability of nuclei. Yes? So what answer is that? We don't really, we cannot say anything there. What's the correct answer for A? Let me see your hand. A, B, C, D. You don't know. Why you don't know about that? We talked about it. Do you remember we said that the stability of the nuclei, that the neutrons are acting like nuclear glue? You remember that expression? That from the observation that as the atomic number is increasing, in order to have stable nuclei, you have to have a lot more neutrons than protons. Do you remember that? So we made a conclusion that the neutrons are acting like glue to hold the nucleus together, the plus charges together, the protons together, like instant. So, as the number of protons increase, the atomic number increases, the ratio of what? Neutrons to protons has to increase. So, reverse that one and get the answer. Reverse that one, that statement, and get the answer. What's the answer? What's the answer? Loud. D. A, D. Correct. Okay, great. Now let's go to the next one, because again, we don't have much to say about it, really. It's something that you need to know from your class, from your study. For 9. Oh, quite a few choices here, no choices problem. What's the answer for 9? What's it? What is for 9? A. Let me see your hands. A. B, C, D, E. Okay, most people got it right. How many people don't get it right? Or they don't know? Let me see your hands. Nobody answers. Why? You don't have an attitude like a little child. All knowledge in college will be wasted. We need to have an attitude like little children. Respect your teachers, obey them. Something in the West is totally unthinkable. But there are cultures that the teachers are respected and obeyed. And they are chosen because they love to teach, not just to pay the bills. And that way they don't have to be evaluated because they already have been evaluated in the hearts of the parents and the students. And that's why they call them teachers. This is the world we want to create. We have teachers that they do it out of love, not for paying the bills. Then we'll see a brighter day. Right? Okay. So participate. Try to participate. It will be good. Participate, like little children do. It's beautiful. Participate. Become one with your teacher. Huh? How about that? Make an effort. Try it. It's very weird to you, but try it. Give it a try today. Huh? Let's do it. Okay. So, by what you know, the answer should be, like most people did, B. Right? There's not really anything to talk about. Explain here. Just have to know it. So, let's go for 10. Okay, here's the answers for 10. What do you think it is? You know how your teacher is doing it. He's asking what, and then you participate, so he gets an idea. How many people don't understand, so he will do it, or just go to the next problem. Please participate. So, this doesn't really take much time to figure it out. If you have done a little bit of work. What do you think the answer is then? For 10. How many people say A? B? C? D? E? Very few people got it right. What do you do for this? We have a carbon which is asymmetric. Can you see that? Chiral center. All the groups are different. Can you see it? All of them are different. So now you put priorities. You have a hydrogen. You immediately know it's the last priority, 4. What's the first priority? Loud. The nitrogen, because that's the highest atomic number, so that's 1. And then between this carbon and that carbon, now by now you really know which is highest priority. Highest priority, lower number. So which is highest priority? This carbon participates double bond or this carbon? The double bond, okay? So 1, 2, 3. That's it. Now what do? You put your face in here, and this lowest priority is away from your nose. And you go 1, 2, 3. 1, 2, 3. Hydrogen, lowest priority is away from me, and it goes 1, 2, 3. That's what? Counterclockwise. If it's counterclockwise, what's the answer? S. And all of that are on their own. How many people, they didn't understand it? Let me see your hands. At the end, okay? Because you've done work, okay, by now. Okay, so at the end, ask how we do it. There are ones that they want to know, and they don't know enough. 10, 11. How would you name this compound? It's pretty easy because it's symmetrical, so you don't have to know many rules. How would you name that compound? You choose the longest carbon chain, yes? There's actually one, there's not many. Isn't that true? Look, you see the carbon chain? Here's the carbon chain. There, that's the carbon chain. And you start from here or from there because the molecule is symmetric. On purpose, I gave it to you easy because when you go to organic, you learn many rules. Now, it's really easy. So it doesn't matter which way you will go, right or left, it's symmetric, right? So, 1, 2, 3, 4, 5, 6, 7. No, it's a heptane, right? Heptane. So this molecule is heptane, all right? Heptane. Then, what do we have? Substituents, in what positions? At 4, and 3, and 5. We have a chloro, and we have two fluorides, difluoro and chloro. You don't take into account the prefixes, letters, just the name. Which comes first, F or C? Chloro or fluoro? F or C? Which comes first? C. So you will have then what? In position of what? 4. You will have a chloro. Chloro at position 4. Yes? Dash. You have at position 3, common 5. What do you have? Dash. And then you have what? Two fluorides. So it's difluoro. Yes? So here, right here, you put, because the way I did it, I cannot put it, you put difluoro. So it's 4-chloro, 3,5-difluoroheptane. So the answer should be E. If you don't get it right, don't worry too much about it. When you go to organic, you'll learn better. Okay? The exam is not going to have hard problems. Okay? Let's go to 12. What's 12? Interesting. Let's do 12. What's the answer for 12? Anybody? Loud. If you were in kindergarten or first grade, when you get it right, or you think you get it right, it doesn't really matter. You just, yeah. Just for the fun of it, yeah. Teacher, teacher. B. Now we are frozen. D? Let's see. D. Where's D? What number we're doing? 12, okay. So how many people say D? Raise your hands. Okay, the answer is D. How about 13? There's nothing really much to talk about. Remember we said if the universe was the most stable form according to our understanding, it would be all of what? What kind of matter? The lowest energy, binding energy of the nuclei. Which element? What isotope? Iron 56. Right? Now this is an infinite universe. This statement we're making as scientists is totally silly. Because we can't even comprehend infinity. What are you talking about? Which is more stable here? What we know, right, we have seen with our brains and our eyes, we feel like iron 56 would be the most stable, huh? And that's why this answer goes to that way. How about 13? What is the answer for 13? C. All the other ones are graphite, diamond, carbon nanotubes, right? They're all allotropes. How about 14? Let's do 14. Expect similar questions in your exam. What's 14 answer for 14? We have done this, I think, in the midterm number 2, I think, if I remember well. What's the answer for 14? Immediately, when you have this type of problems, what do you do? 5 steps. That means, look, reactants, right? 1, 2, 3, 4, 5. That's it. I was not looking even what I was doing. Right? Because every step has what? An activation energy. Is that true? So, 1, 2, 3, 4, 5. 5 steps. Okay? Now, how are you going to answer this? For transition states, with 5 steps, no. Each step had transition state. Transition state 1, 2, 3. Right? All these are transition states. Same number of transition states as steps. Each step has a transition state. Wrong. First one is wrong. There are 5 intermediates. No. The intermediate is always x minus 1. If x is the number of steps. Yes? You can see here. 5 steps. How many intermediates? How many intermediates? 1, 2, 3, 4. 5 minus 1. So, second, wrong. 5 activation energies. You already did the answer. You know that, right? Each step is an activation energy. So C will be the answer. And the rest one is C. Right? Okay. Any question for this? Pretty easy problem. right? You should not miss it. So let's go to the next one. For the electrochemical cell represented, blah, blah. Okay, so identify the reducing agent in the cathode. So think about it for a few seconds, then we'll do it. What's the answer? 15 is what? How many people say A, B, C, D? What means in Greek? Yeah? You know what you're missing? Is the definitions from Chem 2A. That's what you cannot do it. Because you're confused with the definition of what is reducing, oxidizing, reductant, oxygen, which is oxidized, which is reduced. You're confused with this terminology, which I found out to be true for almost every student. That's why in the reader, Chem 2A reader, I have done a really very organized job to be able to, and I always give a problem for Chem 2A students, to be able to become familiar with this terminology. Become familiar with this terminology before you go to organic. You must understand what is oxidizing agent, reducing agent, oxidant, reductant, and so on and so forth, okay? So, let's do it together. What's the process of thinking to do this problem? Identify the reducing agent. The reducing agent will reduce something, and therefore itself will be oxidized. Oxidized means that the oxidation number will increase. Yes? And when we have electrochemical cell, by convention, we put on the left the anode, which is always, for galvanic cells, what? Is oxidation, right? On the left, the anode, which is always oxidation. It doesn't matter. It says electrochemical cell. Who cares? Galvanic or electrolytic. The anode for both will go on the is oxidation. And we write always oxidation on the left. So, which is oxidized then for? Oxidized. What is in the anode? The anode is on the left. Therefore, zinc is oxidized to zinc 2 plus. Yes? And where is the cathode? On the right. Yes? Okay, so what's the answer then? Now, how many people say, how about A, B, C, D? And some people said C. No way. Why would you say C? Why would you say C? Because the definition of the cathode is not a solution, is, well, let's see. What does it say in the cathode? It doesn't say the cathode compartment, it says the cathode. When we use cathode, we mean the electrode. Okay? That's what we mean. Okay? So that means that we have the answer there, B. This problem 16, a lot of students have a problem, they're confused with it. Many times the simplest thing becomes really hard. I've seen students have a problem with this problem. What's the answer for 16? Anybody? How many? A, B, C, D, E. You see, most people don't know how to do it. Many times the simplest becomes the hardest. Define the universe. What is the universe? Huh? What is matter? What is energy? What is an atom? What is an electron? Do we really know? If we say we do, that's why we remain blind. And that is why we have so many physical problems in the world. We're ready to exterminate ourselves because we know. That's what we say. But we really do not know. We know very little. Anybody else? A, B, C, D, E. What's it going to do it? This is an equation that it's a redox equation. Do you agree with that? Every redox reaction can be imagined that you can employ for an electrochemical cell. Theoretically speaking, really, you can say that. So you can imagine we have a cell, and if the reaction is not favored, then the only way to make it happen is to push it with energy in the form of work from the surroundings. Yes? And we know. Hydrogen oxygen, boom, go mix water. It's really a favored reaction, and kinetically is not so happy, but when you put a spark, it goes crazy, explosion. To go from water into H2NO2 is uphill reaction, it's non-favored, and you have to put electricity to make it go, right? And that's exactly what it is now. Now, if you want to know how many electrons are going around the circuit per so many moles of this product or this reactant, the equation has to be balanced. Otherwise, you cannot talk about it. Okay, so you balance that equation. Very easy to balance it, as you can see. And it's going to be what? 2 here. And you have 2H2 and O2. You agree with that? Okay, now, we're going to talk about oxidation numbers here, but really, you can imagine them to be electrons, which is, in this case, true, because you have electrochemical operation. And you can write the half reactions if you want, but that's a waste of time. So you can see oxygen goes from what? -2 to 0. Yes? That's how many oxidation numbers going up? 2. If you write the half reactions, that corresponds to how many electrons? How many electrons? 2. 2 electrons per how many oxygen atoms? How many oxygen atoms? I said from -2 goes to 0. How many oxygen atoms I talk about? 1. That's per 1 oxygen atom, isn't it? 2 electrons per oxygen atom, isn't that right? The oxygen has -2 and goes to oxygen 0. When you say -2 to 0, that's per 1 atom. Isn't that true? Yes. Per 1 atom here, per 1 atom there. And so 2 electrons per 1 oxygen atom. Now, if water has 1 oxygen atom, then you have 2 electron atoms, 2 electrons, per 1 molecule of water. Isn't that true? Yes or not? The ratio of particles is ratio always of? Anybody? Say it loud. Huh? Anybody from 2A here? Always the ratio of particles is the ratio of moles. So, we have 2 moles of electrons per 1 mole of water. What's the answer? Then. I told you, it's kind of so simple that the simplest things many times they drive us crazy. It's true. Okay, how about, well, let's see. Let me see how we do with time. I think we're going to take a break now. So what I'm going to show to you is, and we'll be more respectful to yourselves than to your teacher. If you can sit quietly and enjoy the message, and remember the message, which will later benefit each one of us if we really listen to that message. The reason your teacher decided to do this today, to be dressed with his native costume, is more or less every one of you has roots. You just did not drop from the sky. If you go back and search your generation, how you call this, tree, you will find out someone is from Ireland, someone is from Czechoslovakia, someone is from different places. Almost all of you can trace your roots. Your teacher is telling you, go and trace your roots, find your roots. Because whatever happened in these thousands of years before, or hundreds, it's already in you. We do not know it. It is in our DNA, physical DNA, it is also in the so-called spiritual DNA, or intellectual DNA. You can call it anywhere you want. There are two different kinds of DNAs. The second type of DNA, we have a hard time to understand it. But really it's created from generation to generation. And you can see many times, people are like their grandfathers, their grandmothers. Same good stuff or same bad stuff. And we are called to break the circle, to make it all beautiful if possible this lifetime. So, each one has a different background, more or less. And it's beautiful to know this, how beautiful it is. You go to different cultures, so beautiful dresses, the women, the men, beautiful flowers in their hair, whenever they celebrate different holidays. I was, as you know, this summer in India, and there was a holiday, Anam, they call it Onam, and it was beautiful. The girls, the students at the University of American University, they were so beautifully dressed, so beautiful colors and designs handmade. Their hair were full of beautiful smelling flowers, and they were celebrating and dancing and singing. It was just out of reality. And I come back to the West, I said, what are we doing? The only thing we're doing is, we're trying to have all things for convenience, and at the end our minds are totally confused, unhappy. I said, I got to go back to my students and tell about what I found out. So, what your teacher wants to say today with this costume that he's wearing, and he asks you to do it if you have one, and he's going to do it every review session from now on until he's in Davis, and then he goes away. Whenever he goes away, that message will stay here. It will not go to perdition. It's going to stay. In our world today, we live by learning all the science that you learn, we become powerful. And power brings great responsibility to ourselves. Because 60 years ago, really, we could not really harm the earth and ourselves. But 60 years ago, something happened. And I don't want to go into that, you know very well. And there is an expression in English language, it's called Damocles' sword is above king's head. And in our case, Damocles, you go on the internet whenever you have your Christmas break, Damocles, D-A-M-O-C-L-E-S, Damocles, sword. So I have a Damocles sword hanging in the air exactly on the top of our head as humanity. And just a little bit mistake if we make, that will split our head into two. It will be the end of humanity. That Damocles sword is hanging on the top of humanity's head. And a few words your teacher says, you can understand much. If you go and search the story of Damocles sword, what it says.